right, we are back on our PowerPoint. I moved outside, so it might be a little bit loud here and there. Got some traffic in front of my house here. All right, so we went through ionic kind of, and now we're going to talk about covalent. And covalent still wants to have that octet thing. They want to have 8 outer electrons, but the way they do this is by sharing electrons. And those, I didn't mention before that ionic is typically going to be between metals and non-metals. Okay, where covalent is typically between non-metals and non-metals. So non-metals and non-metals. Where then that tells you that metallic bonds are just going to be between metals and metals. Okay, and they have the outer electrons. They move through the metal. They're kind of cool. That's why we have metals in our wires for electricity, because of those free flowing outer electrons. That's how that electricity can flow through the metal, and it's extremely conductive whenever it does that. All right, so ionic bonds. We kind of already talked about this in the last video, but this is going to give you some more example. It shows you how the sodium, if you were going to do an electron dot notation, which you had to do in chapter 8. So if you don't remember how to do that, it's literally just taking the symbol and putting a dot for however many outer electrons there are. Okay, so you know how many outer electrons there are based on what column it's in. And then same thing for the chlorine. Well, it's in, if you look at your periodic table, let's look again really quick. Chlorine is in group 7. I'm going to erase all of this stuff so that you just see this table pretty much. So chlorine is in group 7. So if I go back to my PowerPoint over here, you can see that it has 7 outer dots. Okay, well, neither one of those are happy because they both just want to have 8 outer electrons. So what's going to happen is sodium's going to lose that outer electron right there. When it does, it becomes positive. And well, really, chlorine's going to it's going to give that electron sort of to chlorine. So then chlorine becomes negative, and then you end up with this NaCl compound. Okay, so the Na loses electrons, the chlorine gains electrons, and that's it. You have an ionic bond. This is just showing you the cubic structure of table salt, which is what NaCl is. NaCl is just table salt. Okay, so energy and electrons and ionic bonding. So I don't know if you guys ever did any kind of chemical reaction lab in high school. Even if you just did one of those volcanoes, you know that how the volcanoes will sort of explode once you mix the vinegar and the baking soda together. Well, if you ever feel it, it produces a heat. And so whenever there is a reaction energy that's being released, that's known as the heat of formation. And so it takes energy, and sometimes energy is transferred as heat. And we should know that because of we did a chapter over energy in chapter 3, and then we also did a chapter over heat in chapter 4, and we saw how they were similar, how they related. All right, so the electron transfer rules. Electrons lost or gained to form that octet, okay? And so it's producing energy whenever that happens. Oh, trying to get that picture. There we go. All right, so this is showing you, well, crud, what it happens if we have, something that has maybe 2 outer electrons in the case of calcium, and then something that has 7 in the case of fluorine. So if we look, and there is going to be some homework that you will have to do that makes you, I don't know how it's going to do it on the computer, to be honest, but it makes you figure out or how to draw it somehow. So anyway, so calcium, it has 2 outer electrons. And let me just bring up the periodic table. Nope. Okay, that's not what I wanted to do. I mean, it is, but it isn't. It's still like figuring all of this technology out. Okay, it's not going to work for me apparently. All right, so if we look at calcium, calcium's right here. It is in group 2, so that means that it has 2 outer electrons. And then it's also talking about fluorine, which is in group 7, which means that it has 7 outer electrons. So I'm supposed to be able to like pull this. There we go. That's what I was wanting to do. Okay. Well, this wants you to use electron dot notation in order to predict what the formula is going to look like. So if calcium gives this 1 outer electron to fluorine here, then the problem is that I still have 1 outer electron. So that's why it's saying, well, in a case like that, you're going to have another fluorine. And it's going to have to give that outer electron to fluorine. So then you end up with calcium. You have 1 calcium, which when it loses these 2 outer electrons right there, so it's right here on the periodic table. It's a metal, so that means it's going to lose electrons. We wrote that down a couple slides ago. And if it loses 2 electrons, then that means that it's going to have an ion of 2+. And then fluorine over here in the 7th group, it has 7 outer electrons, but when it gains one of them, then each one of them, didn't really want to do those dots. I don't know why I did that. When it gains those electrons, then it has a -1 charge, but we have to have 2 of them. Okay, so it's like this, 2+ and 2 fluorines. So you end up with CaF2 because you had to have 1 calcium for every 2 fluorines. Okay, now there's another way, and this comes a little bit later, but I want to go ahead and show you because I just think it is so good to know. It's sort of a shortcut. So what you do is you write the ion for calcium. You know what the ion is for calcium based on what group it is. It's in group 2, so it's got to be 2+. If we were going to do aluminum's ion, it's in group 3. Aluminum, is it a metal? Yes. So it's going to be a plus. So since it's in group 3, it's 3+. Now the non-metals are a little bit different because you don't go by what group they're in. You go by how many back they are. So like, here's the noble gases, and they're like 0 kind of because they don't need anything. But every time you go backwards, so if you go to group 7, then its ion is -1. If you went to the next group, then its ion would be -2. The next group would be -3, and then the next group would be -4. Okay, now remember, non-metals get negatives and metals get positives. Okay, now here's the shortcut that I wanted to show you with this right here. See this number, this 2+? If you drag that 2, not the plus, just the 2, down to the bottom of fluorine, and this negative is basically like saying -1, right? So if you take this 1 and you drag it down to the bottom of calcium, then I would write it Ca1F2. Now, whenever you go to write a chemical formula, you never write a 1. So it's just CaF2. Well, that's the exact
equation that we had over here. Now, I say that this is an example of, this is sort of a shortcut. Now you're going to have to do it using electron dot notation like we did on the PowerPoint slide over here. That is one way that it's going to ask you to do it. So just know how to do both of them. This is a really good way to check your answer.